Okay. All right, so guess what? If I were going to make this, here's what I do. I would carefully take out 42 milliliters of this really powerful concentrated acid, and I'd put it in a 5-liter container, and then I'd water up to the line, and then it would be done. It wouldn't be 18 molar anymore. It'd only be 0.150. I added a whole lot of water, a whole lot of water. What do you think about the dilution equation? Not bad?
No.
The only trick is knowing that's my first molarity, but when I get finished, that's the second molarity, isn't it? And I don't know the first volume, but I do know when I get done, the second volume is going to be 5 liters. Okay, well, anyway, you can practice these tonight, okay? Practice some of these tonight. And before we take the quiz tomorrow, I'll actually go over any of these that you want to try. And I'll have the next mini lesson. Let's go over here to this page right here on the back. So this is the last equation that you would have to know. And here's what it looks like. Oh, I forgot to ask you a high-level question. All right, let me ask you. I think I might have a dollar bill. All right, if you think you know the answer, raise your hand. I want to know why. Come on, come on, come on. Oh, man. Come on. All right, here we go. High level, this is high level. This is like ultra honors class. Okay. Why does M1V1 equal M2 V2? That's the one you're supposed to memorize, right? But why? Why would M1? Wow, that's fast. I'm listening. What's proportional?
Like you do the same thing, both of them, so they do the same.
And I'm not saying that we don't have a proportionality, because any equation could be like this, but why do you say M1 V1 has to equal M2 V2? Why? Give me something in chemistry. All right, Dave, you were second. You had your hand up, yeah.
Yeah, no, all I was gonna say, subscripts denote different values. They're the M2 and M1 are both molarities, but they're not going to be the same number. Because it's
They're not going to be the same number, but who said you could set these equal to each other? What chemistry concept says you can set M1 V1 equal to M2 V2?
Something in them has to be the same.
What now?
Something in them has to be the same.
I'm listening.
They're equivalent.
Well, the equal sign means they're equivalent. I'm going to know why. Why would they be equivalent? Oh, I like that. But that's for a real reaction. You know what? When I dilute something, it's not a chemical reaction, is it?
Oh, because the amount of the original chemical stays the same.
What now?
The amount of the original chemical stays the same. You just add water.
You're getting close. What do you mean when you say the amount?
So like if you start out with a molarity of just one chemical, and then you add it to water, the molarity of that chemical stays the same, but the amount of.
But the molarity actually changes.
Oh right, yeah.
Oh, you are so close. You are so close. What do you think?
Just the concentration is what changes. Like, there's the same amount of, like, you're not taking any away, you're keeping the same amount, but you're just adding something there and changing the concentration.
Does the concentration change?
Yeah.
Oh, so what is it that doesn't change?
Concentration doesn't change.
What now?
I thought the concentration doesn't change.
It does change.
It does.
Just a bigger.
That's why it's diluting. When you dilute it, it started at 18 molar. It didn't end up as 18 molar. It ended up as what? So the concentration does not stay. Something does stay the same.
Because like if it's sulfuric acid, and then you're adding sulfuric acid to water, there's still the same amount of sulfuric acid.
What do you mean by amount?
The similar amount of
Milliliters volume.
Volume's not the same.
I guess
The concentration's not the same. The volume's not the same. Man, you are so close.
And then the weight.
What is it?
Isn't it the ions?
Well, actually, ions don't. I could say ions come into play here, but no. Yes. What?
Does molarity stay the same?
Molarity changes. That is concentration.
The mass?
Man, you guys are so close.
Is it the mass?
What?
The mass?
Well, the mass changes too, but there's something that does not change.
The elements.
What? The amount of water does change.
The elements.
I had a bunch of water. I had a bunch of water to it. A bunch. Gosh, you're so close. That means it's like you couldn't get any closer and not get it.
The number
Every
of
time you said the word amount, you were so close. But what did you mean by amount? The concentration amount? No, that's not it. The volume amount? No, that's not it.
The amount of elements.
What does that mean?
Well, I mean, there's 2 elements in the first one. There's 2 elements out
Well,
the second.
Yeah, but
The number of moles?
why do you say that?
Because, well, if you have a certain number of moles in the sulfuric acid, the number of moles of sulfuric acid when added to water doesn't change.
That's true. That's it. And what is molarity times volume equal?
Moles?
Moles. So this is the number of moles of sulfuric acid I had, and even if I add water to it, guess what's the same? The moles of sulfuric acid. Wow, that was good. So watch this right here. I'll draw a drawing. Here's some really concentrated sulfuric acid. Ooh, leave that alone. That's really concentrated, right? I take a little bit of that and I put it in a really big container and I add a whole bunch of water. Now watch. Ding, 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 ding. I take a certain amount of that and I put it over here. So the amount that I took out of here was so many moles, wasn't it? They're sitting right here. They just get diluted, don't they? But the number of moles that I took out is the same as the number of moles of the chemical that's still there. All right, so now let's take a look at this last one. Now, this is, the one I just did, dilution, was not a chemical change. This one is. Do you remember when it had an acid plus a base? Here, look at this guy here. Here's an acid plus a base. Remember they talked about acids and bases? And do you remember acid and base? Remember that double replacement? Okay. Is that balanced? Yep. Okay, everybody get that? Do you remember that? Acids and bases? Okay, let me ask you this now. Do you know, we talked about this one at a time, do you know what is it about this that makes it an acid? Is it the hydrogen ion or the chloride ion?
Hydrogen.
Right, so the hydrogen ion that's one of the quiz questions tomorrow. What the hydrogen ion is the ion that makes an acid, isn't it? And what ion makes a base a base? Here's a base. It's not the calcium. So what ion makes you an acid? Hydrogen is the ion that makes you an acid. What ion makes you a base?
Oxygen?
Not oxygen.
Also hydrogen?
What is it?
Also hydrogen?
No, hydroxide.
Oh, together.
All right, see that? Okay, now, whenever you have an acid and it reacts with a base, what always happens when the H goes with the OH? What's it always make? And that's not an acid or base. So guess what? Your acid and base get neutralized. So when you add an acid to a base, there's going to be a point where you add enough acid and neutralizes it, and nobody's an acid or a base at all. So whenever you have an acid and you want to combine it with a base, you can actually use this equation right here. All right, so now, there's one little trick, though. There is a trick, and I got to teach you a trick. Okay, you see where it says molarity of the acid? Find the molarity of the acid. Oh, there's the acid. What's the molarity of it?
0.07.
Okay, so now, I'm going to put that number right here. Now, I forgot to ask you a question. How many ions of H are in this? How many ions of H are there?
1.
So if the concentration of HCl is that, what's the concentration of hydrogen ions? The same number. So I'm going to put that there. Okay, here we go. So that's the molarity of the acid. What is the volume of the acid? We don't know because they said you have to find it. Okay. Now, what is the molarity of the base? This is the only tricky part. This is the only tricky part. What's the molarity of calcium hydroxide? What's the molarity of calcium hydroxide? My pen is pointing to it. 0.01. Now, I can't write that down. You know why? Because I don't want the concentration of this. I want the concentration of the ion that made you a base. So for every one of these, how many hydroxides do you have? 2. So what's the concentration of hydroxide?
0.02.
That's the only tricky part. That's the only tricky part. In this case, you have to multiply times 2. And then what's the volume of the base? Oh, here it is. Now, you might say to yourself, wait a minute, on the other equation, I had to change milliliters to liters. You don't have to do that. I'll show you why. Look what happens. Cancel. Cancel. If you want your final answer to be in milliliters, then just leave this as milliliters. All right, so what's your math teacher going to say? How do you solve for x? All right, let's do it. 0.02 times what? 0.02 times 100 divided by this times this divided by that.
26.66.
One more time.
26.66.
Would everybody try that and see what they get? So it's this times this divided by that. This times this divided by that. If everybody would put that in a calculator, I feel really good if everybody got the same answer. Well, what's the units? What are the units?
Milliliters?
It's the only one that's not canceled, isn't it? What'd you get, Lauren? Here, do this. This times this divided by that.
What, 260?
Okay, so somebody got something different. All right, somebody else do it.
I got 266.
How much?
266.
256?
266.
266? 266? Okay, try it again. See if your decimal's in the wrong place here. What'd you get? Leroy, what'd you get? So it's this times this. Yeah, 0.02 times 100. Mm-hmm. Uh-oh. That's another one for you. Another 26. I need somebody. What'd you get? Oh. Now you guys have to do it again. Now you're in the minority.
Do you think you left out the O in the .075?
Oh, did you leave? Yeah, do you have the O there? So 0.02 times 100 is 2. 2 divided by 0.075.
The only way.
What's 2 divided by 0.075?
26.66.
26? Okay, all right. So it's how much of this HCl would I have to mix with that much base to neutralize it? 26.6 milliliters. Now we're going to do one more of these, okay? And then we'll be done for the day. We're going to do one more of this problem. And, okay, this one is so simple. You know why? For every one of these, how many hydrogen ions do you get? 1. So if the concentration of that is this number, then what's the concentration of hydrogen ions? It's that number. Look at this base. How many hydroxides are in that?
1.
Okay. So if the concentration of NaOH is that number, then the concentration of OH is also that number. That's even simpler. We did the hard one first. Let's try it. Would everybody try this one? This is an acid-base neutralization. There you go. There you go. Ooh, I might have another $1. I have another good question. Oh, yeah. All right. Now, you don't want Ryan to get both of these dollars, so. But she might. Can you try this? You don't have a calculator?
No, I'll try it.
Okay. Okay, so what's the molarity of the acid? We'll find the acid. Here he is. See, he has an acid. So 0.115 times the volume. Oh, they don't know that. And what's the molarity of the base? Oh, for every one of those, all right, 0.0875. And 50 milliliters. I'm just going to leave that as milliliters because I want my answer to be in milliliters. So it's going to be this times this divided by that. Now, I'm not giving $1 for the answer. I'm giving $1 for the next question, but I only have 1 minute. So you have to give me the answer and answer my question within 1 minute. All right, so what's this one come out to be? How much, what volume of acid do I need here? Say it again. 330? 380 even? Okay, that's it. All right, let's say that, right? Did everybody get that?
No.
We all need to match. What'd you get? 38? Man,
I got 38.
we're doing a power of 10 thing, aren't we? It's 0.0875 times 50 divided by 0.115. It has to be a decimal place because you have the same answer except for a decimal. What'd you get, Lauren? 38? Who got 38? Who got 380?
Oh, it's 38.
Okay. All right, I have $1. All right. This is hard. This is a hard question. Why would this equal this? Why would they equal each other at neutralization point? Yes.
Because the neutralizer have the same amount.
There's that word again.
The same amount of moles.
Of what?
Moles.
Of what?
The base and then also the
What kind of moles of what here?
base,
What's that?
which is hydroxide.
Okay. What about? Yes. And you know what? When these are equal, everything's neutral. Here you go. Good job. This is moles. This would be moles of hydrogen ions. This would be moles of hydroxide ions. And when they're equal, everything's neutralized. There you go.